In January 2025, wildfires ignited across Southern California. Within hours, they stopped behaving like fires and began operating as a system beyond control. There was no single front to fight, no clear edge to hold. Fire appeared in separated locations at once, connected by wind, fuel, and terrain rather than flame. Streets burned without collapsing. Power remained on while neighborhoods ignited. The city did not fail structurally, but fire moved through it anyway. This did not look like a disaster unfolding. It looked organized. Fire advanced directionally, responding to airflow, not resistance. Once fire stopped spreading randomly, suppression stopped working normally. The event crossed a threshold where control was no longer a decision. This is the moment wildfire stopped behaving like fire. It no longer spread randomly, and instead began operating as a coordinated system driven by wind, terrain, and time. Long before the first flames appeared, Southern California was already primed to fail. Months of drought stripped moisture from land and vegetation, leaving the region burr-ready by late 2024. Seasonal grasses dried into uninterrupted fuel beds, connecting wildland areas directly to suburban neighborhoods without natural breaks. Urban expansion placed homes directly inside fire-adapted landscapes, turning city edges into ignition interfaces rather than protection zones. Fire prevention systems assumed fires would remain localized. That assumption depended on weather patterns holding steady. When Santa Ana winds arrived, those assumptions collapsed instantly. Wind did not intensify the fire. It prepared the system to move. By the time ignition occurred, the system was already assembled. Fuel, wind, terrain, and urban density were aligned before the first response could begin. Nothing that followed was improvised. The outcome was already set, shaped by conditions locked in place long before the fire ever touched the ground. Once the winds locked in, fire no longer spread outward from ignition points. It advanced directionally, transported forward by airflow, rather than expanding through direct flame contact. Embers lifted into the air and traveled kilometers ahead of the main fire front, landing far beyond any containment line. Fire stopped behaving like a continuous line. It appeared simultaneously in separated locations, connected by wind rather than distance. Containment lines were designed to slow surface flames, not airborne ignition. At this scale, those barriers quickly became irrelevant. Highways, rivers, and cleared corridors no longer acted as brakes against the fire. They became pathways aligned with the wind, accelerating spread instead of stopping it. Fire behavior became directional, not radial. Spread followed airflow patterns instead of expanding evenly from a source. Ground crews focused on edges that no longer existed. By the time one front was engaged, several more had already formed. The fire stopped responding to suppression tactics. It responded only to wind speed, terrain slope, and the continuity of available fuel. As winds persisted, flame fronts multiplied faster than they could be addressed. Control failed not tactically, but physically. At this point, fire was no longer confined to the ground. Its behavior was shaped by airflow and heat above the surface, turning the event into an atmospheric system. Modern cities are not built to interrupt wildfire systems. Streets, blocks, and zoning organize movement for people, not for wind-driven fire. Roads did not slow the fire. They aligned with airflow, channeling heat and embers deeper into the city instead of stopping them. Buildings did not act as barriers. They created turbulence, lifting embers over rooftops and multiplying ignition points, block by block. Roof materials ignited from radiant heat alone, without direct flame contact, collapsing the idea of defensible space at urban scale. Power lines and infrastructure did not fail safely. They became ignition networks, extending fire faster than flames could travel on the ground. As ignition points multiplied, response time collapsed. Fire departments were no longer facing one fire, but hundreds at once. Urban geometry did not stop the fire system. It amplified it, converting density into fuel and layout into acceleration. At this scale, control was not lost through human error. It was structurally removed by the way modern cities are designed to function. Evacuation assumes fire moves slower than people. In January 2025, that assumption collapsed as fire spread faster than human decision-making. Smoke arrived before flames. Visibility dropped across neighborhoods long before evacuation routes were fully activated. Traffic density matched the speed of fire expansion. Roads designed for daily flow became bottlenecks under simultaneous evacuation. Emergency communication lagged behind the system. Alerts moved through networks slower than the fire moved through terrain. Individual choice lost relevance. Survival depended on location, not reaction time, as the system advanced uniformly. Evacuation failed not because people ignored warnings, but because too many were already positioned inside the system at the same time. When evacuation must occur everywhere at the same time, it stops being a response. It becomes a physical impossibility. This is how scale turns lethal. Not through panic or chaos, but through simple arithmetic that no human system can outrun once it begins. As the fires expanded, heat output began altering local airflow. Rising columns of hot air pulled oxygen inward, strengthening the very winds that fed the flames. Fire no longer waited for weather to change. It started generating its own movement, reshaping conditions minute by minute. As temperature increased, humidity dropped around the fire zone. Fuels dried faster than suppression could cool them. This feedback loop removed the final margin for control. Fire was no longer reacting to conditions. It was creating them. Suppression capacity is finite. Once energy output exceeded removal capacity, the outcome stopped depending on tactics. At this point, the fire no longer depended on continuous fuel lines. Embers and radiant heat crossed every break, bridging gaps that once defined containment. Time became the dominant factor. As long as those conditions persisted, the system continued to operate steadily, regardless of human intervention. Control did not fail suddenly. It faded step by step as the system expanded beyond the scale that human response was ever designed to handle. This event was not unprecedented because of size. It was revealing because it showed how modern wildfire systems now behave under locked conditions. Forecasting did not fail. Warnings were issued days in advance. What failed was the assumption that prediction alone could interrupt the physical system. Modern suppression is designed for events that move slower than response. This system moved faster than deployment, logistics, and coordination. As climate conditions shift, fuel dries earlier, winds persist longer, and the window for control narrows every year. What changed was not human effort or response. It was the boundary between fires that could be managed and fires that operate at the level of a system. Once that boundary is crossed, outcomes depend less on human decisions and more on the physical conditions that continue to drive the system forward. This is why these wildfires felt unstoppable, not because they were uncontrolled, but because they were operating within the limits of physics. The fires did not end because they were defeated. They ended when wind weakened, humidity rose, and the system lost the conditions it depended on. What remained was not chaos, but persistence. Burned neighborhoods, altered terrain, and a system that had finished operating. This was not a failure of courage, response, or effort. It was a collision between human systems and physical limits they cannot override. When fire becomes a system, control is no longer a choice humans can make. It becomes a condition that either exists within the environment or does not. In Southern California, the fire did not break the rules of nature. It followed them precisely, and the outcome reflected what those rules always produce at scale.